Imagine you're trying to eavesdrop on a whisper happening inside a stadium during a heavy metal concert. Impossible, right? Well, Google just did exactly that, but with quantum particles. And honestly, the entire scientific community is losing their minds right now. Today, we're talking about Google's quantum echoes. And trust me, this isn't just another quantum computer goes brr story. This is the moment quantum computing stopped being a really expensive science fair project and became actually useful. So here's what happened. Google's quantum team just ran an algorithm on their WILLOW chip that's 13,000 times faster than the world's fastest supercomputers. And before you say, yeah, we've heard this before, hold on. Because this time, they did something nobody's ever done. They solved a real problem, verified the answer, and it actually matters for the real world. Let me put this in perspective. They ran 1 trillion measurements. That's not a typo. 1 trillion. That's more measurements than most quantum computers have done in their entire existence, combined. It's like someone told you they counted every grain of sand on a beach, then did it again just to be sure, then did it 10,000 more times for fun. Now, here's the thing. About quantum computers up until now, they've basically been doing party tricks. Impressive party tricks, sure, but party tricks nonetheless. It's like watching someone juggle flaming chainsaws while riding a unicycle. Cool, absolutely. Useful, debatable. Back in 2019, Google announced quantum supremacy. Their computer solved a problem that would take a classical computer thousands of years. Everyone clapped. But here's the dirty little secret. The problem they solved was specifically designed to be hard for regular computers and easy for quantum computers. It's like bragging that your sports car is faster than a bicycle on a racetrack that bicycles aren't even allowed on. But quantum echoes? This is different.
This is verifiable, repeatable, and it solves problems we actually care about. It's the difference between juggling flaming chainsaws and using those chainsaws to build a house. So what exactly is quantum echoes? Think about how bats navigate in complete darkness. They scream really loud, then listen for the echo bouncing back. That echo tells them where the walls are, where the bugs are, everything. Google did the quantum version of that. They took their WILLOW chip with its array of qubits, ran a series of quantum operations forward, then poked one qubit like a tiny quantum effect butterfly, then ran everything backward in reverse. The forward and reverse signals crashed into each other and created this echo pattern. And that echo, it reveals hidden information about how quantum systems work at the deepest level. It's measuring something scientists call an out-of-time order correlator, which is a fancy way of saying how different parts of a quantum system gossip with each other across time and space. Imagine you could see how a rumor spreads through a high school, but the high school is made of atoms and the rumor is quantum information. Now, you might be thinking, if this is so useful, why hasn't anyone done it before? Great question. The answer is because it's stupidly difficult. Remember that whisper in a stadium during a concert? The signals quantum echoes is looking for are that faint. They're buried under mountains of quantum noise and errors. It's like trying to hear a mouse sneeze during a rocket launch. But Google's WILLOW chip is just that good. Its quantum gates are so accurate they can run thousands of operations while keeping errors under control. They're using superconducting integrated circuits that offer precision other quantum computers can only dream about. Plus, they've got clever noise mitigation techniques. They're not just brute forcing through the chaos, they're strategically silencing it so the important signals can shine through. And get this, they can do milliseconds of measurements in under 1 minute. That speed is absolutely critical because you need massive amounts of data to confirm your results. So this is it. This is the inflection point. Quantum echoes isn't the finish line. It's the firing of the starting pistol. For years, quantum computing was a promise of a distant future. With this, Google just dragged that future into the present. We're now looking at a tool that can start tackling the impossible problems, designing new drugs, creating revolutionary materials, truly understanding the universe. The party tricks are over, the real work has just begun.
Let's get into the WILLOW breakthrough. This is what makes it the superhero of the story. Last year, Google announced that WILLOW solved a problem that's been a ghost in the machine for quantum scientists for nearly 30 years. That problem? Errors.
With quantum computers, adding more power, more qubits, always meant adding more chaos. It's like a group chat. 2 people, it's fine. 5, okay. 50, it's a total mess. Messages go to the wrong thread, notifications are a nightmare, it just doesn't work. But Willow smashed right through that wall. They figured out how to dramatically suppress those errors as the system gets bigger. This isn't just an improvement, this is the difference between a high-tech paperweight and a machine that can actually change the world. Okay, so what does this actually do? Why should you care? This is where it gets real. You know MRI machines, right? The tubes that let doctors see inside you without a single cut? They use a technology called NMR spectroscopy. Scientists use that same tech to figure out the 3D shape of molecules. And why does shape matter? Because in biology, in chemistry, in materials, shape is everything. It dictates how a protein folds, how a battery stores energy, how a drug interacts with a cell. But NMR has blind spots. There are things it just can't see. So Google teamed up with UC Berkeley. They used an algorithm called quantum echoes on the WILLOW chip to predict the structure of 2 different molecules. Then they checked their work in a real lab with a real NMR machine. The result? A perfect match. I don't mean close enough, I mean perfect. But here's the kicker. Quantum echoes also saw things the standard NMR couldn't. It measured longer distances between atoms, accessed data that was previously invisible. This isn't a replacement for our tools, it's an upgrade. It's giving us a new sense to perceive the world. And that new sense could trigger a revolution in drug discovery. Let me paint you a picture. Right now, making a new drug is like playing with the world's most expensive Lego set blindfolded. Pharmaceutical companies build thousands of different molecules, test them all, and hope one of them works. It's a billion-dollar guessing game that can take decades. Now imagine this. Instead of building and testing, you simulate. You use a quantum computer to accurately predict how a molecule will behave before you ever make it in a lab. You could design the perfect drug on a screen, know it will work, and then synthesize only the winning candidates. This could slash years off development time, billions of dollars saved, but more importantly, lives saved. Think about diseases we currently can't touch. Imagine designing treatments for them in months, not decades. So what happens now? Google is talking real-world applications within 5 years. And that doesn't even feel optimistic anymore. They've proven the algorithm works. They've checked it against real-world experiments. They've shown it's 13,000 times faster than our best classical supercomputers. All that's left is scaling up and refining it for specific jobs. That's not a scientific mystery, that's an engineering challenge. It's hard work for sure, but the path forward is clear. Within 5 years, we're talking quantum-enhanced drug design, quantum simulations for next-gen batteries, quantum models for creating new materials. This is a fundamental shift in medicine, energy, and science itself. This is the moment quantum computing stopped being science fiction and started being science fact. Google didn't just build a faster computer, they built a new kind of microscope, one that lets us see the machinery of nature in a way we never could before. And that changes everything. If you enjoyed this breakdown, share it with someone who needs to know what's coming. Trust me, we are just getting started.